Hello, my name is Ken. I was diagnosed with central retinal vein occlusion in 2002. I'm not a doctor and I have no medical training, so remember to consult your physician without delay when making medical decisions. Ischemia is a word used to describe a tissue whose blood supply has been reduced to an insufficient level. Let's take a minute to look at this condition as it occurs in the retina. The retina is a light-sensing tissue that covers the back inside wall of the eye. To properly function, it must have oxygen, nutrients, and a way to dispose of its cellular wastes. These needs are usually met by two circulation pathways serving the retina. The first pathway serves the retina from the inside of the eye. In a normal eye, oxygen-rich blood flows into the inside part of the eye via the central retinal artery, shown here with red dots. Oxygen-depleted blood leaves the inside part of the eye through the central retinal vein, shown here with blue dots. The central retinal artery and the central retinal vein access the eye through a narrow channel in the optic nerve. As the central retinal artery enters the back of the eye, it branches into smaller vessels until blood reaches almost all areas of the retina's surface. After the blood has made its way through the capillaries and delivered its nutrients and oxygen to the surface layers of the retina, the blood leaves the eye through a similar system of veins. Underneath the retina is a second pathway of circulation that supplies blood to the retina. This system's primary component is called the choroid. The choroid is a network of blood vessels situated in the wall of the eye underneath the entire retina. Here the choroid is shown in yellow and the retina is shown in orange. The choroid is supplied oxygenated blood through a number of arteries, shown here in red, which enter the back wall of the eye at a distance from the optic nerve. These arteries are called posterior ciliary arteries. In real life there would be several more of these arteries extending into the back wall of the eye. As these arteries enter the wall of the eye, they branch into the choroid, the vast network of vessels underlying the retina. After the blood has circulated through the capillaries of the choroid, the oxygen-depleted blood flows into small veins that coalesce into larger veins. These larger veins exit the eye and are called vortex veins. So these two circulation pathways supply blood to the retina. The central retinal artery and the central retinal vein supply blood to the retina from the inside of the eye, while the choroid supplies blood to the retina from underneath the retina. Inside the retina, these two pathways work together to nourish the retinal nerve cells. The retinal vessels bring oxygenated blood down to the top two layers of retinal nerve cells, while the choroid takes care of the lowest layer of nerve cells. During a central retinal vein occlusion, as the central retinal vein becomes obstructed, the backup of oxygen-depleted blood in the retinal veins prevents oxygen-rich blood from freely flowing through the surface layers of the retina, and the retina is at least partially starved for oxygen. In the other pathway, because the circulation of the choroid depends on the vortex veins and not on the central retinal vein, the blood supply of the choroid is not interrupted by a central retinal vein occlusion. The choroid continues to supply oxygen to the retina. Unfortunately, this circulation is not always enough to prevent areas of oxygen starvation. Short interruptions of blood flow from the retinal vessels may have no lasting consequences. The nerve cells are able to survive. But longer interruptions of blood supply may set in motion a progression of cell death. This cell death is evident in blind spots or diminished vision. Oxygen starvation in the retina due to reduced blood flow is called retinal ischemia, and any tissue that suffers from ischemia is said to be ischemic. In this video clip, the word ischemic has only been used to describe the condition of a tissue, but the word ischemic is also used to indicate a particular type of central retinal vein occlusion. Central retinal vein occlusion is traditionally classified as ischemic or non-ischemic central retinal vein occlusion. Ischemic in this context refers to a disease classification. So with the word ischemic, context is important. Is the word ischemic being used to describe the condition of a tissue or as a disease classification? The difference may be important. For example, just because the eye has an area of ischemic tissue does not necessarily mean that the person has been diagnosed with a case of ischemic central retinal vein occlusion. A term closely related to ischemia that you may hear is perfusion. Perfusion has to do more precisely with the flow of a fluid or the pouring of a fluid. Where blood flows through the vessels of a tissue, that tissue is said to be perfused. Where there is a lack of blood flow, the tissue is said to be non-perfused. A test called a fluorescein angiogram is used to look for areas of non-perfusion in the retina. To illustrate this test, we'll use a simplified drawing of the back inside wall of the eye, with the retinal arteries in red and the retinal veins in blue emanating from the optic disc. In this test, after fluorescein dye is injected into the arm, the dye travels through the circulatory system. As the dye enters the back of the eye through the central retinal artery, a series of black and white retinal photographs are taken. The retinal arteries brighten up first as the dye flows into the eye, followed by the retina as the dye makes its way through the capillaries, and finally the retinal veins begin to brighten up. The macula in the center of the picture remains dimly lit because there are fewer surface vessels in this region. In an eye with areas of non-perfusion, the dark area where the dye is abnormally absent may represent areas where the retinal capillaries have completely and permanently closed off. This closing off of capillaries is called capillary dropout or capillary obliteration. One way of assessing the extent of non-perfusion is to use the area of the optic disc as a basic measuring unit. So in this example there are about 4 or 5 disc areas of non-perfusion. To sum up then, retinal ischemia is an after effect of central retinal vein occlusion, which occurs as retinal tissues receive a blood supply that is inadequate to meet its functional requirements. A normal rate of blood flow provides the retina with oxygen, nutrients, and a way to dispose of its cellular waste. After a central retinal vein occlusion, however, blood is prevented from freely flowing through the surface layers of the retina, and despite 2 pathways of retinal circulation, areas of retinal ischemia with retinal dysfunction may develop.